Left off yesterday, we had talked about, once again, the components of the skeletal system. Let's go back over those real quick. Cartilage, bone, tendon, ligaments. We had looked at the structure of the osteon. Okay? So, the osteon, all right, we are looking at that as a component making up the bone, all right? Then we talked about the bone cells themselves. We talked about the blast, the sites, the clast. Then I introduced you to that one called the osteochondral progenitor stem cell. We left off talking about the different shapes into which we classify the bones. So we classify them into long, short, flat, irregular, all these four classifications. One of the things that I tried to point out yesterday when we were talking, I tried to point out this connective tissue wrapping that we find around the bone that of course contains those stem cells and other cells that are needed for bone. If you remember, bone, very dynamic, okay, not static. And when we left off yesterday, I purposely stopped at this point right here. Bone development. When the bone development occurs, this is sort of what we're going to be looking at. We're looking at egg and sperm meeting, fertilization occurring, and development that will take place in utero. Now, what do I mean by that? What does it mean when you hear in utero? All right. Developing in the womb. Regine's running late, but I can't stand all this noise. So you see, okay. All right. In utero means development is taking place in the womb. Do you happen to remember when egg and sperm meet, one cell becomes two, two becomes four, four becomes eight, and so forth, what we give rise to? We give rise to 3 germ layers. Do you remember those?
Oh, so bad.
We get the mesoderm, endoderm, ectoderm, where eventually that's going to become, skin, it's going to become muscle, it's going to become internal organs based on the germ layers. Something else that is present when we have all of this development, even now as an adult, we have membranes. All right, do you happen to remember some of the membranes that we've mentioned? Well, you're thinking about the membrane around the cell, but think about membranes in the body as a whole. We've got our mucous membranes, we've got the serous membranes, okay? When development is occurring, when we begin to look at development in utero, the majority of what's going to take place is called intramembranous ossification. Because the first things that form are the membranes. And then we have to get hardening of the offspring. Now, itty bitty baby in utero, some of it bone, right? However, what is the majority of itty bitty babies' skeletal makeup? Cartilage. And then, and what's the reason for that? So we can out the birth canal, okay? The head of itty bitty baby. Okay, I've put one on all the tables, all right? Some of the head, itty bitty baby, is bone, right? But then, this one right here, this one's pretty major, because we refer to it, what's another name for this one right here? The soft spot. Okay, because itty bitty baby gets here, and and it's like, and everybody's like, don't touch the soft spot. Okay, watch the head. Don't touch the soft spot. Why?
Soft, so you can do some damage. They say it can kill it, right?
Yes. Actually, what it is, the brain, okay, the reason that we have this, and note how they're trying to show us the structure not being completely lined up, okay, because you're going to actually have membranous portions throughout all the bones of the skull, because it allows for the movement that's going to take place through the birth canal. That's why, when itty bitty baby gets here, and if there's been too much squish going through the birth canal, head might be a little bit lopsided, okay? And then, what do? They tell you, okay, well, lay it more on its back, or lay it more on its side, or lay it more on, because these bones are still squishy, okay? It will help to, hopefully, get their head into the nice round shape. Okay, sometimes, whole little thing, gotta get a helmet for it. Okay, and it has to sleep in the helmet. Okay, because, the bones have just gotten too out of line.
So, when you lay, babies are laying on their backs too much, can it really?
Yeah, it can really flatten. That's why it's a good idea to roll them. Every so often roll. But what happens, Kenesha, is if there would be too much pressure, because even though the bones are here, okay, if there were too much pressure there, that's going directly to the brain tissue. It is going directly into the brain tissue. So when we begin to, where all that noise is coming from? Now, when we begin to look at this, okay, egg for me. I gave you that number down. Okay, the first, because of the germ layers that get created, it's these membranes that are present, all right? And therefore, we're going to have to give rise to the tissue that will become hard and bone. So the first thing that takes place is something that has to occur inside the membrane. Therefore, intramembranous. Does that make sense? So, once we get that first formation, and the majority of itty bitty baby, when it gets here, it's going to be a lot of cartilage. The majority, they have some areas that are hardened. We know that, okay? But for the most part, the babies are delicate, all right? We handle them carefully. We watch them grow up, all right? We watch them change, okay? There are a lot of cartilage until they reach their final height, okay? Which means for women, roughly that 18 to 20 years of age, and men got 21 to 24. There's still a lot of cartilage. Now, granted, the older we get, the more we grow, the more bone that's showing up. But you know, if you think about children, when they break a bone, it heals very quickly. You know, it heals much faster than what you see with an adult, okay? Now, once the baby gets here and most of the cartilage that's present is there, well, the next thing that has to occur is we have to make sure that the growth and the development and the change can take place. So what we have to now focus on is something called endochondral ossification. Now, let's take the term apart, because once again, if the child is mostly cartilage, we now have to make sure, because chondral tells us cartilage, right? Endo, inside, all right? So it tells us that we now have to see the ossification inside the cartilage. Both of these methods give us, hopefully, what we're going to see as an adult, which is our compact bone surrounding spongy bone. So that is the goal. We start out, remember this from yesterday, where we've got a lot of our collagen fibers, okay? And then we're dependent upon the blast laying down the hydroxyapatite, and then as the growth and the change and the remodel and everything that occurs, we're dependent on all of those cells working together to give us what we see as the adult skeleton. This right here. So basically what I'm telling, you know, what I'm trying to relay, we start out with the membranes that are going to help to give rise, okay, to bone. Some of that stays, especially in the head area, okay? Then, as we form in utero, a lot of it is cartilage. Baby's born, baby's got to grow, change, then throughout life, we're going to have all this remodeling and renewing and everything else take place, okay? And we end up with our adult skeleton. Now, kind of glad that my leg down here ain't quite like that, all right? You kind of turn around and twist it just a little bit, okay? But our adult skeleton with the 206 bones. The reason that children have more bones, they're not considered the bone until they close up and ossify. So, for example, the coccygeal region, okay, those bones as a child are not fused yet. So they're counted as all separate bones. So that would mean more than the 206, all right? So we don't count it as the full bone adult-wise until the ossification has occurred.